Hello students, welcome to today's session. Today we are going to discuss about Ohm's law, their limitations, resistance, Kirchhoff's law, and about the electric shock. In previous sessions we have discussed about the potential. So what was potential? Potential difference is also called as voltage or supply or battery or electric pressure. So what exactly it did? We have movement of charges. And these charges, they move from the lower potential to the higher potential. So what voltage do? He applies some force to build the charges from negative terminal to positive terminal. So we apply the voltage try to move the charges. And what is resistance? Resistance is something who try to oppose the current. So this is the thing we are discussing in this chapter. So now let us discuss about the limitations of Ohm's law. So what it says? It says that the resistance of material changes with temperature. Every material have a various kind of behavior. Every material behave in different way. Every material's properties are different. So according to them, the resistance of particular body changes because the changes in the temperature. Few materials are good, few materials are bad. We have discussed in the earlier classes. Gold is also a conductor, copper is also a conductor. But both of them do not have same amount of conduction. So conduction varies when resistance changes. You change the resistance and the conduction will change. So according to material, it changes. What are the drawbacks, the limitations of Ohm's law? Ohm's law is not applicable to the semiconductors. It is applicable to only conductors. Second, it is not applicable to the gases. So we can apply Ohm's law to only the conductors. And in conductors also, it depends on the temperature. If temperature changes, the resistance changes. These are few limitations of Ohm's law. The thing we have to remember that it depends on the temperature in conductors. Then next, we will discuss about a technical statement, and we will try to develop a method by which we can imagine how exactly the circuit is working. So let me read this statement and we will see how to imagine them in 3 dimensions in our mind. So it reads as, when a conductor is connected to a battery, the free electrons start moving with a drift speed in a specific direction. During the motion, the electrons collide with positive ions fixed of the lattice and come to halt. This means that they lose mechanical energy in the form of heat due to electric field that was set up by the battery throughout the conductor. These electrons regain the energy from the field and proceed to move. The motion of electrons is obstructed by the lattice ions. The obstruction offered to the flow of electrons in a conductor by lattice ions depends upon the nature of the material. Now this is a lengthy statement given in a paragraph. Now what we have to do, this is a very simple statement, this is a very simple concept. We have to imagine with the actual physical appearance. So what it says, it talks about the internal resistance and it also tells why conductors do get heat, why they become hot. If you operate a mobile phone for a longer time, if you use more application, you play more games or more heavy games which require more space, your mobile phone gets heated. Why that heat gets created inside a phone? Or if you use more gadgets and if their consumption of current is increasing, they become hot. Why it happens? Because inside all the gadgets there are various materials. Materials will have their internal resistance. Now let us imagine we have a cylinder. That cylinder, excuse me, let me close this one. Okay. So we have a conductor, it is a material. Inside conductor, there is a flow of electron. Conducting wire, we imagine that it is a cylindrical shape. Any wire, if you expand it, it will look like a cylinder. So what do we have inside conductor? Inside conductor, we have positive immobile ions and the electrons are moving inside that particular conductor. When they move, when we apply a battery, negative terminal and positive terminal are connected to battery. We have to consider it. Now what happens? There are many electrons. What is saying? This electron may strike on some particular positive ion. He is fixed. So if he strike on a particular ion, what will happen? It will slow down. His speed will reduce after bombardment, and it will release some mechanical energy in the form of heat. And it may also get reflected in some other direction. But when it happens, at the same time, the battery is applying the force. So what will happen? This electron will again come back into the motion and it will keep on flowing. So this will go into the flow. Again it may strike somewhere, and then the electric field will make it move in the same direction again and again. So inside material, what electron observe, the obstruction, the opposition to the movement of electron, that is nothing but the resistance. If it is happening inside the material, it is called as internal resistance. And when they strike on the immobile ions with higher speed, and if their velocity increases, if they release more heat, then we get our device more hot. So this is the concept of resistance. So what is the moral here? Obstruction to the motion is internal resistance or material resistance. Every material will have its own internal resistance. Similarly, we will have external resistance, that we will see. So what is a resistor? There are so many gadgets we can use. We can have components, ICs, capacitors, resistors, LEDs and all. What is our discussion right now? It is about resistor. Resistor may have various sizes, right from few centimeters. So there are various values of resistors. The unit of resistor is ohms. We calculate resistance into ohm. So there are various color bands on resistors, by using which we can identify the value of resistor. Resistor may be say 1K, 1000 ohms. It may be 10K, that means 10,000 ohms. So that we will see in the practical session. It will continue after this explanation. So these are the resistors. Now these resistors we use in a circuit. We connect them in a circuit to control the current. Why to control the current? In particular section we may require more current, particular section we may require less current. So for that purpose we use resistors. These are external resistances. Internal resistance, what we have discussed, does not appear. We can't see that. It is internal to the material. It depends upon the material properties. But external resistors are created for opposing the current in a circuit. So now resistors we can connect in series or parallel. If we connect resistors one after one, it is a series connection. If we connect resistors across each other, this will be termed as parallel connection. Now we can calculate the resistance of the device. Now there are 4 resistors. If we know the value, we can sum all these series resistances and get a single value of resistance. We will call it as equivalent resistance. Say let us see the example. Say we have the resistances in series and parallel. So there is one example where resistance is connected in parallel. We have a supply voltage, positive, negative. The current is flowing. Now what is happening? Current is coming from the battery, and there is a division. Now current will reach say this point. Now after coming to this point, it has 2 paths. Either it can go to the straight path or it can go to down. It will get divided into both the parts. So we will get I1 and I2. So I1, say half current will go to the R1 and remaining half current will go to R2. So there is division of current between these 2 resistors and they are connected in parallel. How to calculate parallel resistance? For that we have a fixed formula. So we represent the total resistance by R equivalent. So 1 upon R equivalent will be equal to 1 upon R1 plus 1 upon R2. Now in this circuit you can see that resistance is connected in series. Whatever current is coming from the voltage source battery, the entire current is going across the resistor. There is no division of current. There are no two paths for the current here. So current is same current I will flow in the entire circuit. What will have changed? The voltage will change. Here voltage is always calculated between 2 points. These 2 points have same voltage as these 2 points, and these 2 points have same voltage as R2. But here we have two components. Two components means at both the component ends we will get voltage drop. So one voltage is given here. This voltage will be divided among this R1 and R2. And how we will calculate the total resistance? If they are connected in a single line, we will simply add them. So R equivalent for this case will be R1 plus R2. If we have three resistors connected in series, so say we have R1, R2 and R3, all of them connected with a battery in series. So what will be the total resistance for this? It will be R equivalent equal to R1 plus R2 plus R3. So like this we can calculate the resistance. Let us see the examples. So if we simplify this one for parallel, so we can write it as R equivalent is equal to 1 upon R1 plus 1 upon R2. It can be given as R1 R2 divided by R1 plus R2. So let us have one example. So this is example 1 where we have three resistors. Three resistors are there. The values are 10 ohm, 20 ohm and 30 ohm. They are connected in series. So what are the values for this one? This is R1, the value is 10 ohm. This is R2, the value is 20 ohm, and R3 is having value of 30 ohm. So what will be the total? They are in series. So R1 plus R2 plus R3 will be addition of all these three resistances. So final value will be 60 ohms. Similarly, if you want to calculate them in parallel, for parallel we have 1 upon R1 plus 1 upon R2 plus 1 upon R3. So R1 is 10, so 1 upon 10 plus 1 upon 20 plus 1 upon 30. It will be 11 upon 60. If we calculate this value, we will get the R equivalent as 5.5 ohms. So like this we can calculate the equivalent resistance for series and parallel connection. So say one more example where we have three resistors, 1, 4 and 8 ohms. They are connected in series. So what he is saying to calculate the circuit? He is asking us to calculate the R1. So R2 and R3. So we have 1 ohm, 4 ohm, 8 ohms. And the total value is 20. So 20 is equal to addition of all those things, and we have to find out R1. So please calculate R1 and post it in the comment. Let us check who posts the correct value and who is watching the video in live streaming. So you have 5 seconds. Say 5, 4, 3, 2, 1. So this value is 8 ohms. So those who did comment, I appreciate them. They are genuinely watching the video in live stream. So this is the question for assignment. This one you have to solve and post it in the available form. So here you have two resistors connected in parallel, 4 ohm and 12 ohm, and both of them are in series with 7 ohm, and there is a voltage supply. So first you have to find out the equivalent voltage for these two. That value will be in series with 7 ohm. If you add them, you will get the final value of resistance. This is your assignment for this section. Then let us discuss about the Kirchhoff's law. There are two laws of Kirchhoff: Kirchhoff's current law and Kirchhoff's voltage law. Kirchhoff's current law, what he says? if we consider a point where number of wires are attached together, if there is a single wire, no matter, there will be same amount of current will flow. If some point comes like a circle or a ring road where number of paths are going, so if some current is coming to that particular junction, he may have various paths to go out. So any junction where number of currents are incoming and number of currents are outgoing will be same. Whatever amount of current comes, the same amount of current will go out. We cannot get any additional current automatically. So whatever comes, that goes. So let us see if we have one node where say I1 and I2 are coming towards the node and I4 and I3 are going away from the node. So from these two parts current will come. So if our current is negatively charged particles, electrons, so what will happen? We will have say two currents coming from I1 and I2 and they will go towards I3 and I4. So the addition of the incoming currents will be always equal to the outgoing current. That is Kirchhoff's current law. We will see examples of these along with voltage in another session. So addition of I1 plus I2 is equal to addition of I3 plus I4. Similarly, we have Kirchhoff's voltage law. What he says? It says that summation of all the voltages present in the circuit will have a value of 0. So this voltage plus voltage across this resistor plus voltage across this resistor, the total of all these three resistances will be equal to 0. So we are applying a supply voltage, we have resistor 1, we have resistor 2. It is a closed path, there is no division of current, there is no divider, there is no junction, there is no node. So same amount of current will flow across the circuit. Now the elements are connected in series. So these 2 points will have a voltage that will be divided among R1 and R2. So if we talk about the V1, what will be the V1 value? Let me rub this. So for this, say supply voltage is Vs. So for calculating the overall voltage and the values, what we have to do, we have to start from a reference point. Any one point we will start. Say we are starting from this point and then we will complete the closed path. We have to come back to this point and we have to calculate all the voltages in that. So first element comes resistor. Now then we will write the voltage across resistor. What is the formula? What is the relation between current, resistance and voltage? It is given by Ohm's law. What it says? It says V is equal to IR. So if it is R1, voltage across R1 is say V1. So we will have I into R1. So this is voltage drop across the resistor R1. Now this is voltage R1. Here we have to give the direction. We have to remember one thing about the direction of sign. Either it will be minus or plus. How it will, we will decide. It will be the direction of the destination. How we have to see the destination? Suppose this is positive, this is negative. If I want to go across this battery and I have to decide the sign. So it is going from minus to plus. So I will consider it as plus. Now here positive is connected to this end. So this point of resistor become positive. So left side is positive. So right side is connected with the negative terminal. So if I start from this point, I have to go like this, the clockwise. So in my clock, first element is R1. So R1 is going from plus to minus. So this one I will write as minus I R1. Then it is going to the next resistor. In next resistor, what will be the voltage? Again, V is equal to IR. So that V is equal to IR and R is R2. So the sign is positive is connected to the upper point, negative is connected to the lower point. We came like this, then we are going down. So we are going from positive to negative. So its sign will also be minus. So it will be minus I R2. Then we are coming to the final element. This is the Vs, voltage supply, where we are going from minus to plus. The short terminal is minus, the longer terminal is plus. So it will be, we can write plus Vs. So what it says, the summation of all the voltages will be equal to 0. So from here we can say Vs is equal to, these two terms we will shift to RHS. So V1 will be equal to IR1 plus IR2. So we are having supply voltage divided between these two resistors. So this IR1 is nothing but say V1, and this IR2 is nothing but V2. So total voltage is equal to V1 plus V2. So this is how we calculate KVL. So KCL and KVL, Kirchhoff's voltage law. In short form, we will call it as KVL. Its example we will see in another video. So then next term is power. At home we get electricity bill. We get current, we get voltage, so we get the bill. How we get? If we consume more amount of current, we get more amount of bill. So how they calculate the bills? They calculate the power in terms of watt. The unit of power is watt. How much watt we are using? That means how much voltage and current we are using. So they take it as the product of voltage and current. The power is calculated as the product of voltage and current, and that power is nothing but it is multiplied with the fixed value of rupees, and that multiplication we get as the bill. So now if you have observed the bulb, if not you take a bulb, on the bulb there will be rating. For example, if a bulb is marked as 60 watt and 120 volt, there will be written on the bulb what are the values. Excuse me. So if someone asks you to calculate the resistance of that bulb, how will you calculate? So what do you have? You have power given in watt, and you have say voltage, but you don't have resistance. You have formula P is equal to V into I, but there is no resistance term V into I, but you have V. So you can replace this I from Ohm's law. What is it? I is equal to say V by R. So we will keep this value here. So we are keeping V by R here. We will get P is equal to V square by R. So from here R we can calculate. So what will be the value of R? So 120 is the voltage, V square, 120 into 120 divided by the power 60. So resistance will be 240 ohms. If you have a bulb with 60 watt and 120 volt, what is meaning of this statement? That means it will use 120 volt, and in 1 second it will consume 60 watt power. Are you understanding? If you use more wattage bulb, will you get more light bill or less light bill? You will get more, because in that 1 second he is consuming that much power. If you are using more wattage, you will get more bill. So it is power, the wattage, the energy spent per time. That is about the power. So this is our another assignment example for this video. First thing you have to calculate resistor and power for this particular circuit where voltage is 10 ohm, current is 2 ampere. So you have to calculate resistor and power, and in this example you have to calculate the current. If each resistor is of 240 ohms, all of them are 240 ohms, and the voltage supply is 120 ohms. So first you have to calculate equivalent for this R1 and R2, and then that equivalent value will be in series with this R3. That total you have to check. So we'll continue about the shocks and the damages overloading in next session. Till then, have a good time.